In this video, we're going to show how you can take different materials in iMachining and show how the feeds and speeds and stepovers are adjusted between them. So the first thing we're going to do is we're going to work on this ledge right here. And we're going to start with aluminum as our default feed and speed library. So here we have aluminum. So we're going to add a 2D iMachining operation. First thing we're going to do is define our geometry. Here we have a semi-open pocket, so we're going to pick our chain. So that SolidCam knows what edges are open, we're going to say mark open edges, do from to, pick from here to here. Those edges become black. They're now open edges. We'll define our depth off of the floor here. We can see it's 850. And we'll call this ledge 2. We'll go select our tool. Here we have a 1/2 inch end mill with 4 flutes set up. We'll talk about how 4 flutes can actually work with aluminum very well in switching between materials after we're done with the presentation. So let's move to our technology wizard. We're working on level 4. What we see here is we have a programmed RPM of 6,000, 98 inches a minute, with a 75,000 step over. If we calculate and simulate the toolpath, here we see the iMachining toolpath, clearing that ledge off with a cycle time of 11 minutes. Now, what happens if we wanted to change this material to cut, let's say, stainless? So we go back to our CAM part, and we scroll through our list. You can see in our list we have 78 default feeds and speeds. We want to go to, let's pick stainless steel, hit OK. You can see it now wants us to pick which operations we want to be updated. We want to update that roughing ledge. Tells us we need to edit the operation. When we go to edit it, it wants us to know, do you want to turn the wizard on and synchronize? Yes, we do, since we're actually going to use these feeds and speeds. When we now go to our technology wizard, let's look at what we have. The RPM changed from 3,400 RPM from the almost 6,000. And the feed rate went down to 66 inches a minute. And we also see that the step over changed. So what this is showing you here is that iMachining and its speeds and feed library is not a database of feeds and speeds. It is an actual algorithm that is running and looking at tool, material, depth of cut, and adjusting all of them to keep all of them synchronized perfectly. If we calculate this toolpath and go to our simulation, and we play through it, now we see when we move to stainless steel, we now have a 26-second cycle time. As I talked about earlier in the video, we used a 4-flute end mill. Generally, most customers using or cutting aluminum are generally using 2-flute and 3-flute end mills. Generally, this is done because in aluminum you can overload your chip load to very high amounts. So in standard steel, with a 1/2 inch end mill, we'd generally be running around, let's say, a 3 to 3.5 thou chip load. When it comes to aluminum, we can overload the chip thickness all the way up to like 6, 7, 8 thousandths. But when we do that, we need to have chip evacuation. So this is generally why in aluminum we're using 2 and 3-flute end mills. When it comes to iMachining, since we actually look at how many flutes we have, we synchronize the perfect chip thickness. If you were to use a 4-flute end mill in aluminum with iMachining, you'll see that there's really no difference in feeds and speeds. Yes, when we use a 4-flute end mill in iMachining, we're not going to overload the chip thickness to that 4, 5, 6, 7, 8 thousandths chip load that we were doing with the 2-flute end mill in aluminum. But if we look at the fact that in iMachining we would be running a 3 thou chip load with a 4-flute cutter, if we double the 3, we're actually looking at 6 thousandths. So when you do the comparison between 2 flutes and 4 flutes, with iMachining, since we're controlling everything, your cycle times really aren't going to change by going from 2-flute to 4 flutes. So for customers that change materials a lot, cutting steel and aluminum, if you invest in 4-flute carbide end mills, you'll have great cycle times and great compatibility to switch between aluminum and steels very easily. Let's also take a look now at the differences of what happens if the depth of this feature actually changes. So first, let's note some couple numbers here. we see we have a program step over of 44 thousandths when cutting this 850 deep. Well, what happens if we went out in SolidWorks and we said this feature is no longer 200 thousandths thick? It's 450 thousandths thick. We'll save and rebuild the model. We're going to tell it to check synchronization since we're doing it on the fly. We can see here that our pocket depth needs to be updated. We're going to tell it to synchronize. We're going to go now into the operation and take a look and see what the technology wizard did. Now we can see the step down went from the 850 to the 600 thousandths. Here's the key we see here. The step over actually increased. Because iMachining is always looking at the step over and for the depth of cut, we can adjust and optimize the step over for each depth of cut. So as we're doing shallower depth of cuts, we're able to increase our step over. So we went from 40 thousandths to 62 thousandths in this case.